In this question, we have two separate circuits. And even though they're independent, they're linked by means of this current-dependent current source, where the current coming out of it is twice I1, and I1 is the current in this branch of the other circuit. And the question is asking for V out, so we need to find this potential. And to do that, we would need to find this current, and to do that, we would need to find this I1 to put that into the dependent source. So our problem now is finding I1. So you might want to convert the current source to a voltage source, but I'm going to try my luck with Kirchhoff's voltage law, or Kirchhoff's current law at that node. So I'm going to say Kirchhoff's current law says that the currents entering the node should be equal to 0. So let me just label this current here as I2. So you've got 5 milliamps entering and I1 and I2 exiting the node. So I can say 5, if I'm dealing in milliamps, it'll be 5 minus I1 minus I2 equals 0. That probably looks nicer if I were to say something like I2 equals 5 minus I1. Okay, so that's the result of Kirchhoff's current law, and that sort of makes sense because you've got 5 milliamps going in, and I1 and I2, it splits, so I2 will be 5, take away whatever goes into I1. Okay, so that's the first step. Second step, I would probably look at this potential here. Let's call it something like VP, because you have these parallel resistors. Why are they parallel? Because they're connected at both ends. So VP is the product of the current, each current multiplied by its resistance. So I1 times 10 is equal to I2 times 2.5 equals VP. So let's write that out and see if it helps. So VP equals 10 I1 equals 2.5 I2. So now we have two unknowns. And that's where the equation we just found using KCL will come in handy. So I can say 10 I1 equals 2.5 into 5 minus I1. And we can open the brackets or divide by 2.5. Let's divide both sides by 2.5. So 4 I1 equals 5 minus I1, rearrange I1 equals 1 milliampere. So that's really good. We just found I1. Now, the question isn't asking for I1, it's asking for V out, but we find V out by multiplying this current by 5, and this current is twice I1. So it's looking good. We can now say that the current, let's give it a name, I3. We can say I3 equals 2 I1 equals 2 milliamps. And finally, V out equals I3 times 5, or times 5k. No, my find the K. So I3, we just found that to be 2. So it's 2 times 5, which is 10 volts. It's volts because that's kilo ohms and that's milliamps, and we're allowed to do that. So that's your final answer. V out equals 10 volts. How did we do it? We first found the current in the left-hand circuit and used that to inform our dependent source on the right-hand circuit. Then we just multiplied the current times the resistance to find the potential. Now, how did we find this current? You could have used the current divider rule. I don't like that. You could have converted this to a voltage source. I chose to use Kirchhoff's current law. And then I said this potential is equal to this potential. And we ended up with that. I mean, the VP here isn't the important part. I can put that in grey. The important part is saying that however you calculate it, whether it's this current times this resistance or this current times this resistance, you get the same thing. So I hope you found that helpful.